Hey there, everybody. It's Cosmic here, and we're just watching the sunset. Just watching the sunset. Oh, trying to focus. Having trouble focusing. You can see the rest of the sky is blue and clear. Hey there, Miss Lady Catherine. Yeah, it's another great sunset in the southwest. Thanks, Uncle Bill, for the feedback. So, just getting into sunset now. I'm so glad that I can see the chat. That makes it that'll make this a little bit easier. So, still seeing sunset. The first thing that I have to do when I do an observing run is I have to take calibration data, which means I have to take, well, primarily I have to take flat fields. And flat fields require a uniformly illuminated field. And one of the ways to do that is to wait for the sun to set. There it goes. It's done. It's gone. So I'm going to wait for the sun to set a little bit. You can sort of see behind me here. Let me move out here. You can still see that the mountains back there are still, it's really hard to see through all this stuff, but see the mountains back there are still lit up. So yeah. All right, I'll take you back over here. I'll quickly show you the setup. There's the scope. There's the computer, and yes, that is a doggy crate or a kitty crate, however you want to put it. But there's the setup for tonight. I've got the camera cooling. It's thermoelectrically cooled, so I have to turn it on and let it cool down for a little while before I can actually start collecting data. So I think what I'm going to do maybe is I'm going to try to get this set up here so you can sort of see, yeah, the brightness of the sky is going to mess with things for a little while. But what I'm going to do is I'm just going to go over and check my let's see. Yeah, I'm just going to check the temperature of the camera. It's probably cooled down by now, and I'll put it on the scope, and then I'll show you how I do flat fields. So got to turn it on first. Turn on the scope. So yeah, I'm definitely at temperature, so that's okay. So I think we can go there. Always remember to take the cover off. Okay, so we'll get the scope mounted, or the camera mounted. Got to do that by tilting this guy down. Here, I'll show you the inside of the scope there. There it is. There's the mirror down there. Okay. Make sure that you're Make sure that you're still set up okay. Yeah, it's not the greatest. That's not the greatest view, but yeah, it'll do. It'll get darker. So putting the camera on the telescope, being relatively careful with alignment. It's not really that important, but I do it anyway. I just use set screws to put this extremely important camera on here, so I make sure that those screws are nice and tight, and then I sort of wrapped the parallel port cable around so there's no tension on that. So then, let's see, am I still in the field of view here? Yeah. Yeah, we're doing it from the outside because I'm taking calibration data for my observing run tonight, and you know, my sunset sort of coincides with the start of Astronomy Daily Live. So welcome everybody, and yeah, I'm just getting set up to do that. So I do a very sophisticated flat field. It's called a t-shirt flat. So this is just to give the camera a nice, smooth, uniform field of view. So that's nice and white and flat. So then I'm going to point it over towards the sun, or the sunset. And I'm going to start taking flats. It's a nice, beautifully clear night. It's going to be, the wind is nice and calm. I hope you can hear me okay. And sorry, you're up on a little platform here. Let me do that for now. See, you can see my camera right here. There's the computer. That's where I'm going to be for a second. Okay, so I got to set where I'm going to store all my files. So I just make it today's date, 18/05/04. Open that, and it's going to be that, and we're going to start at 0, and I'm not going to do autosave yet until I actually look at an image, flat field. So I'm going to do a series of 2-second images here, and I'm going to look at the maximum value to see how it looks. Because yeah, now I have to really start moving fast. So it's a 2-second exposure, and it takes about 15 seconds or so to download, and then I'll see what my value is, my maximum value. I want it to be about 50,000, between 40 and 50,000. Oh, it's overexposed still. Okay, cool. That's good, because as the sky gets darker, the maximum value will drop, and so I've got some good timing here. So I could actually probably do a 1-second exposure, which I think I would try. We'll see what a 1-second exposure looks like. So I really, the timing on this is critical in order to get the best data you can. So, okay, so that's 41,000. I think I'm going to go with that for 10 exposures. 10 exposures at that. And I got to make sure to turn on my auto save. Come on. Okay. It's the correct filter, which is no filter. Series of 10. I'm going to point this down a little tiny bit more to get a little bit more light in there. As I point it towards the sun, of course, I get a little bit more light. Alright, so I'm taking my first series of flats. These are 1 second long flats. I'm going to take 10 of them. I'll sort of bring you in here. You can see my terrible, embarrassingly terrible flats. Let's see. And I don't know if you can see the, I'm going to try to bring you in here so you can really see what's happening here. But these are flat fields. And what you're seeing there is just very, very out of focus, like pieces of dust for the most part. But you can also see that it's sort of brighter down in this area and darker here. And that's just a sensitivity thing as far as the camera goes. And I don't know if you can see it or not, but you see this max value there? It's currently 34,634. That's pretty good. That's pretty good. I'm not too worried about that. I'd like it to be maybe about 44,000, but that's okay. And as you can see, those values go down every single time. So this piece of software is called CCD Soft version 5. It's an old version of CCD Soft. Everything that I've got is old. It's an oldie but a goodie. But yeah, that's what sort of a pretty typical flat field looks like. It's a little dirtier than what I would sort of want it to be, but actually the variations there, right, between the darkest and the brightest is like plus or minus like 5%. So, barely anything at all, really. It's just how it's being scaled, right, how it's being stretched. So this is downloading flat field 9 out of 10. Now I'm going to make sure that these flat fields are actually there. Let's see. Where do I put that stuff? Oh yeah, here. And then here. There they are. Okay, so they're all there. And it looks like that series is done. And we're at about 28,000. So now I'm going to increase this to 2 seconds. And I'm going to take 10 more. And I've doubled the exposure time, so I should more or less double the maximum value there. So we're going to be probably around 45,000, 50,000 or so. Here, let me... here we go. So 54,000. That's very awesome. That's very awesome. Now I'm going to have to remember what exposure times I've taken here as well, because I need to take dark dark fields for all these exposure times as well. So I'm going to have to take a series of 1 second dark fields and a series of 2 second dark fields. And probably what I'll do after this series of 2 second dark fields is done, I will also do a third series and maybe even a fourth. You know, it's one of those things with most science being done. The more data you have, the better. The more data you have, the better. So, sort of depends on how dark it gets, how the counts are going, and as you can see, I'm already down to 48,693 in terms of a max value there. As soon as the sun sets in the desert, it starts to get cold. So I'm actually going to go and put my sweatshirt on over here, which I somehow remembered to bring outside. Now, I would think that watching data being collected probably isn't the most exciting thing in the world, but I'm sort of calling this maybe an IRL. I just recently learned what IRL stands for, so this is definitely in real life. This is the real deal, collecting data. So. Yeah, I'm in southeastern Arizona, Bobby. I'm about an hour east of Tucson. I'm in one of the darkest parts of the state. Okay, so there's that one, and now we're down to about 38,000. So I'm going to bring that up to maybe three seconds. And I'm going to take another series of 10. So 1 second series of 10, 2 second series of 10, and now a 3 second series of 10. And let's see what this max value is. It should be around 50-some thousand, right? 53,981. Ooh, that's sweet. That is the sweet spot. I don't want it to be 65,535 because that's saturating. I also don't want it to be too faint because then I don't really get a good sense of the sensitivity of the CCD. I want to be about 2/3, ideally about 2/3 to 3/4 of the way to maximum. So 50,000 is it's gorgeous. Yeah. So as soon as these are done, that'll be 30 flat field images, and maybe I'll take another series of 10. All your content is IRL by streamer standards because it's FaceTime. Okay, yeah. There's, the one. I mean, all of this, Uncle Bill is sort of a production of sorts, right? I mean, I'm not usually out here, talking at a smartphone, so it's not totally real life, but it's about as close to real as you can get. And just to prove that I'm here, I can do that and go hello. Okay, there's 9 out of 10, and we're down to 40,000. So this is going to be a really, really, really nice set of flats. I like it. And I think what I'm going to do is I think what I'm going to do is I'm going to tilt the scope up a little bit once this is done, of course. To get it a little darker, seeing a little darker field of view. Oh, I see Venus. Venus has just popped out. So I'm seeing Venus. So I'm going to move the telescope up a little bit, and I'm going to do a series of 4-second exposures. And we'll see how those look in terms of max value here. It should be well, hopefully around 50,000 again. That's what I'm aiming for. Let's see how good my aim is. Usually not this good. So, 39. Okay. All right. I'm gonna move this down a little bit during the download. I want to see a little more light than that. Okay. Yeah, 37. It's getting a little low, but that's not terrible. So now it should go up a little bit because I've moved the scope pointing towards the sunset a little bit more. Yeah, what I'm doing, Miss Lady Catherine, is I'm taking flat fields. What flat fields do is they measure the sensitivity of the CCD camera, as well as measure any kind of defects in terms of the optics. So this is a measure of gain, right? So it's a multiplicative kind of a thing. I'm measuring sensitivity of the pixels here themselves. And I'm also measuring, as I said, any kind of optical defects. And as you can see, I've got a bunch of dust, out of focus dust, and all that is part of the optical path, which affects the gain. So this is part of the calibration process. What I'll do is I will take all of these, all 40 of these, and I will average them out, add them up, create what's called a master flat, and then I'll apply that master flat to all of my actual science data, which I'm going to be taking later tonight. Now, I mean, it doesn't get dark here for another hour and 15 minutes or so. And I'm not going to keep you that long, I don't think. I'm not going to be able to actually do star alignments for at least another 20 minutes or so, because I mean it's still pretty bright out here. Okay, so now I'm doing my last flat field. So yay, my flat fields are done. Now I have to take dark fields, okay? And dark fields are a measurement of the electronic noise. It's basically like a DC offset. So what I'm going to do is so I've got to take darks for every exposure time that I took flats for. So I'm going to go back to my 1-second exposures. I'm going to change this to a dark. That just tells the camera to not open its shutter. So it's not going to be exposed to any outside light. It's just going to be seeing its own internal, like electronic noise, thermal noise, anything else. And that is just a DC offset. But I've gotten my flats, okay? And the flats are the most time critical things because I'm using, light from the sky. And during sunset, sunset only lasts a certain amount of time, so I sort of have to rush. Now, whew, I can relax, I can chill, I can take my time and just take my darks, because I'm not going to be looking at any more actual photons from the sky, right? I'm just going to be looking at noise, and you'll see that over in the images here. It'll just look like staticky noise. So let's go through a series of 1-second exposures. I'll do 10 of those again. It's saying dark, so it's not going to expose itself to any kind of light. Sometimes I put the cover on at this point, but I shouldn't have to. So I'm just gonna start that. And the other thing I'm gonna do is there we go. My driveway out here is gravel, and so kneeling on gravel is painful. So I got this big piece of cardboard that I lay down on the ground when I have to kneel, like what I'm doing now, and that helps the knees. So Bobby, I've got a Celestron Nexstar 8SE. It's an 8-inch telescope. I like to call it a 0.2 meter telescope, because that makes it sound, much more important. So you can see that the max values here now are 875, right? So it's not seeing any light except for its own internal stuff. And I don't know if you can see, can I zoom in? Ooh, I can. Okay. Let's see. Can I move around? I can do that. Okay, so what you're seeing, right, is a bunch of these white dots. Those are called hot pixels. Those are pixels that there's something wrong, and they're just going insane, right? I've also got, you can sort of see right here, I've got sort of a bad column as well, sort of starting at that hot pixel and going down. So here, I'll zoom back out, I think. Can I zoom back out? Please, let me zoom back out. Yeah, thank you. Okay, cool. You can see that the sky is still pretty bright. Here, I'll sort of zoom around a little bit here. I can, okay, my first series of darks is about done. So let me, these are the 1-second long exposure darks. So now I'm going to do a series of 2-second exposure darks. And again, I'm going to go over and make sure that these files are actually being saved. Yes, thank you. You always want to check that. Okay, so now I'm going to do a series of 10 2-second exposures. And, I'm choosing 10 sort of arbitrarily. As I said, the more data I have at this point, the better. But 10 is sort of okay. 10 is okay. Not going to really complain about that too much. Not too much. So Venus is getting brighter and brighter and brighter over here. I wonder if I can use this camera to, let me see if I can show you Venus. Whoop, where'd it go? There it is. There's Venus. Out of focus Venus. I don't know if I have much camera control here. I probably don't, so I'm not going to be able to focus on that really any better. Whoa. Oh, now let me try to get it focused on a distant object, and then we'll switch to Venus up here. There it goes. So there's Venus. Yay. I'm not really seeing any other stars yet. Should start seeing Sirius. Oh, there's Sirius over there. Do you want to look at Sirius? Let's see, where is it? There it is. You see Sirius right there? Whoop. Oh, there it is. Twinkling. You see it? Trying to zoom in on it there. There we go. There's a really, really noisy, sort of probably out of focus Sirius star. It's pretty cool though. Live streaming Sirius. It's pretty low, right? I mean, it's probably 20 degrees, maybe 30 degrees, yeah, 25 degrees above the horizon, so it's pretty low. I'm going to zoom out here. You can go back to, so it looks like, yeah, it looks like I'm almost... Okay, so my series of 2-second exposures is done. Now I need to do my series of 3-second exposures. And the darks are easy. I'm also going to take a series of bias images too. Bias images are 0-second exposures. So they're sort of incorporated in the darks already. Ooh, now there was a cosmic ray. That's called a cosmic ray. Right there. Pretty cool. See those all the time. That's a, you know, probably a proton or maybe like a helium nucleus that just so happened to hit the CCD camera during that 3-second exposure. So you see that pretty regularly. There's a couple of, there's one there. There's another one right there. I can move this over and see the whole thing. Zoom in a little bit. Just looking at noise is just, I know, terribly, terribly exciting. Let's look at Venus again. This is getting brighter and brighter and brighter up there. Look at that. Isn't that cool or what? There's Venus and the sunset. Yay. Well, I hope everybody's sort of enjoying this different version of Astronomy Daily Live. I've been going for 34 minutes already. Holy moly. Pretty amazing. Yeah, so the stars are starting to pop out now. Let's see, do I see Capella yet? Yeah, I see Capella. I see Sirius. Betelgeuse, I should be able to see Betelgeuse. Yep, there's Betelgeuse. Now, Rigel is really low over there. I'm not seeing Rigel yet. It's still in the glare of the sunset, but yeah, isn't that just an awesome view, Gilles? Yeah. But it's the real deal. There's my hand. Hello. All right, I'm pretty much done with my 3-second exposure dark image. There was a big cosmic ray there. Okay, so now I'm going to do my 4-second exposures. 4. Like that. So what I'll do with these is I will average each of the different exposure times, the 1, the 2, the 3, the 4 second exposure times. And sorry this is tilted slightly. Yeah. Yeah. And then before I create my master flat, I will subtract these dark images from each of the flats, because the dark image is a it's like a offset, like a DC offset. It's like a platform, right? Where the flats is a measure of gain. So I subtract the darks first, and then I create my master flats that way. So okay, let's go back to Venus here. There we go. And Sirius, you can probably see Sirius by now. A little bit easier. Let's see. Yeah, there it is up there. You see it? Right there. Arizona sunset, man. Almost nothing better. So there's the star Sirius, twinkling away. Let's see. I can probably zoom in on that. There we go. There's an out of focus Sirius. Pretty noisy. Pretty twinkly. I can do the same for Venus. Let's see, let me unzoom that, and I'll come over here and I'll zoom in on Venus here. Oh, where'd it go? Where'd Venus go? Hello, Venus. Where are you? There it is. Come on. All right, there's Venus. Out of focus. We are not seeing the actual disk of Venus there. We're just seeing an out of focus, pixelized Venus. Now notice that Venus is not twinkling. Okay? Planets do not twinkle, but stars do. So when you're looking up in the night sky and you're sort of seeing, it's like, well, is that a planet or is that a star? Notice if it's twinkling or not. Now, Venus and Sirius are at about the same elevation above the horizon right now. So we're looking through the same amount of air, but Venus is not twinkling and Sirius is twinkling like crazy. And the reason is because Venus is a extended object, right? Sirius is so far away. It's so far away that it is a point source. It's a point source, and so we see scintillation from point sources, but with extended sources like this, and if you look carefully, you can see that some of the pixels actually are scintillating, twinkling a little bit. But because it's extended, they sort of cancel each other out. And so you don't really see a lot of that. I'm going to zoom back out here like that. And I'm going to take my biases. I think I'll take like 30 bias frames. And of course, the there's no exposure time on the bias frame, so I don't have to set that, and I'm going to take 30 of those just for fun. You know, as I said, you know, the bias is sort of part of the dark, so it's not really necessary to take a bias. They're not going to be really applied to the data I'll be taking later tonight, starting in about another hour or so. But it's sort of a nice way to sort of get a sense of, you know, how noisy the electronics is, just the electronics themselves. So now I can let me back this up a little bit, and I'm going to take my T-shirt off of the scope. Get the cardboard out of the way. So that's called the T-shirt flats, because it uses T-shirts. And that's how they do that, boys and girls. Now, another thing that I have to do with this scope is I need to sort of tell the telescope mount that it's got this extra weight on there. So I'm going to do that. Menu. I always forget exactly where these things are. Scope setup, I think it's utilities. Calibrate, go to. So this just sort of tells the computer, you know, it does a couple of measurements, it slews around a little bit just to sort of get an idea as to the weight distribution. So it's just sort of a handy way of making sure that, you know, the telescope mount isn't being stressed too much, because this extra weight on here, apparently this mount is only spec'd to support 12 total pounds of weight. So that includes the tube and anything else on this. And I think that I'm probably overweight here a little bit, and probably unbalanced as well. But, well, that's how it goes, I guess. I'm going to get this back around here because I've got my power cable is being stretched a little tiny bit to the telescope, so I'm going to swing this back around. And I'll show you the inside of the scope again. There it is. Well, you can sort of see inside there. Getting a little dark. Kind of hard to see now. So let's see how I look. Okay, yeah, it's getting pretty dark out here. Getting pretty dark. But yeah, I've got another, I think astronomical twilight ends around 8:30 p.m. my time, which is about another, well, a little less than an hour from now. So let's see, I don't think there's, so there's Procyon up there. Here, let me, I can give you a little tour, some kind of little tour of the sky. So there's Venus again. Nice big bright Venus. Trying to focus. Having a hard time focusing. There we go. So there's Venus. And then, oh, there's So there's Venus, there's Sirius, and then up here, can you see? I'm not seeing it in my screen. Oh, okay, maybe up here. Yeah, right there is Procyon. Betelgeuse is... Oh, you can see that too. There's Betelgeuse. So Venus, Betelgeuse, Sirius, and Procyon. And over here, there is Capella. There's Capella. Very cool. I don't think, let's see, over here is Arcturus. There's Arcturus. And Spica, can you see Spica? Ooh, barely. Right there, do you see it? There's Spica right there. So there's Arcturus, and there's Spica. So that's looking sort of east and southeast. I think that's about it. So yeah, just a beautiful, beautiful sunset. Usually how they are around here. Pretty nice. Pretty nice. So tonight's agenda for my observing is I'm going to be observing binary stars, some bright binary stars. Because what I'm still trying to do is I'm still trying to characterize this system in terms of photometric quality. And what I have been doing is I've been looking at open clusters. I've been looking at like M41, M46, M36, M67, because it's got a lot of stars and a nice variety of magnitudes. But my accuracy and precision on those, for some reason, isn't as good as I sort of even expect. So I'm not quite sure why. There could be a number of reasons. One of them might be that the stars are just a little too faint and I'm not getting a good enough signal. So one way to deal with that is to change the exposure times. Ooh, we've got an owl flying over. That's a great horned owl. Cool. We got a bunch of owls around here. So one way to deal with that is to change the exposure time. Here, I'm going to switch to me. Can you see me? Yeah. As long as you keep talking, my face will be lit. So one way to deal with that is to change the exposure time. There we go. Oh, Bobby, can I see the Milky Way? Now I'm exaggerating a little bit, but where I am, the Milky Way casts shadows. So yeah, it's very, very, very bright. Very bright. Easily seen. So I can change the exposure time, but because I'm not guiding, my tracking on this scope isn't all that great. So more than like 2 or 3 second exposure, the stars start to streak, right? They start to streak, and I can't deal with that. And I need to look at the camera, which is over here, right there. I can't do long exposures. So because these are relatively faint stars, 8th, 9th, 10th, 15th, 16th magnitude stars, my signals are very, very low. So I'm thinking that if I look at some brighter stars, um, then maybe my accuracy and precision will change and improve. So I'm going to be looking at some bright binary stars tonight. I've got about 7 or 8 of them I'm going to look at. I'm going to collect lots and lots and lots of data. Going to be out here for a few hours, and we will see, because then what I'll be able to do is I'll be able to measure the differences in brightnesses between those two stars and compare those differences with a known catalog like Gaia, right? Um, Gaia just so Gaia just released their latest catalog a few days ago, and so I can look at the differences in brightnesses as they measured it and compare it to what I get in this scope. And the hope is that they will be pretty much the same. So that's sort of the plan for tonight. I've got, as I said, I've got another I've got another hour or so, a little less than that. Um, I can actually probably start doing my star alignment now. Um, hmm. Should I? Should I keep going on this live stream and let you watch me struggle with star alignment? It's actually not that bad. It's actually not that bad. But the problem is that it's just going to be getting darker and darker and darker, and you're not going to really be able to see anything. Um, as it is, I'm having to um, hit my screen to keep the comments going in the chat, because that's my only light at this point. It's my only light, and I'm really, really close. Sorry. um, Uh, so yeah, you know what? I think I'm going to end this live stream for um, um, tonight. As I said, I've got about another hour before I actually start collecting data for tonight. But I got all of my flats, and they look great. They look really, really great. I got all my darks. I got all my biases. So I I am a happy astronomer at this point, because I got all the calibration data I need in order to take the data that I'm gonna um, get tonight, and very connection. Oh well. Um, and because for some reason this thing is in panic mode now. So all right, I'm gonna get to looking at the first series of stars to do my star alignment. Then I'm gonna hang for a little while, and then I'm gonna start observing these binary stars tonight. So yeah, I hope you like this sort of change in format. I thought it'd be fun just to try it, see how it goes. Yeah, it's getting really, really dark now. So here, I'll show you Venus one more time. It's starting to get really, really dark. There's Venus. There's Sirius over here. There's Sirius. Betelgeuse right there. So yeah, starting to get pretty dark. Pretty dark. All right. All right. Well, thanks, you guys. I will see you again in a little less than the usual amount of time. A little less than 23 hours. No night vision at all. None. Absolutely none. All right. I think this was really, really fun. So I'm gonna have to do it again. All right. Take care, and I will see you tomorrow on the spin. Bye. How do I stop it?